Hi guys, welcome to my channel Science for All by PK. Today we are going to talk about light. This is chapter 10 CBSE syllabus. So today we are going to cover laws of reflection, types of mirrors, mirror formulae, laws of reflection, types of lenses and lens formulae. So let's start with laws of reflection. Laws of reflection you have done in earlier classes also, but let's revise and see what it is. Suppose this is a mirror, plane mirror, and this is a incident ray. After hitting the mirror, it will bounce back or reflect back in the same side. At the point of contact, if we make a normal, this is 90 degree, then we are ready to define laws of reflection. The first law says ray of incidence, ray of reflection and normal on the surface where it is getting reflected all lies in the same plane. What does it mean? It means this ray, normal and reflected ray, if I see a plane, all are in the same plane. That means if ray is coming like this, it will not come like this, or it will not go in any other direction. That means it's not a 3D structure. Light is not coming like this and going in some other direction. It's coming in this, normal is here and reflection is here. Law number 2. If I say this is angle of incidence and this is angle of reflection, in that case angle I equal to angle R. So these are two laws of reflection. Let's revise. Number 1, all three incident ray, reflected ray and normal all lies in same plane. Number 2, angle I and angle R both are same. Now let's see what are different types of mirror. So normally we have seen in earlier classes plane mirrors, which is like we use day-to-day life, which is plane, and we use a daily morning when we go to school or go to office. That's plane mirror. In this syllabus we are going to do spherical mirrors. Spherical mirrors is, if you take a sphere, please don't get confused by circle. Circle is a planar structure. When I am saying it's a sphere, it's looking like a football. Out of that football, suppose this big is a football and I cut one portion, then I get some structure like this. Now in this type of structure, this side can be reflective or this side can be reflective. Normally we do opposite side one polish and then we use other side to see the images. So we have one structure like this. This indicates this side is not reflective, this side is reflective, and it's customary that we always take light from left side. If I am standing like this, this is my left, so always we take left light coming from the left side. Now I am able to draw only 2D, but actually it's a 3D structure like this, so I am seeing it from the side. If I draw a line which goes through the center of the mirror, this line is called principal axis. Because it was a sphere, there has to be a center. This center is called center of curvature, and this is radius of the sphere. This is called radius of the sphere, and the center of the structure is called pole. This is denoted by C. Now, this we have discussed, but we have not discussed what is the types of mirror. As I said earlier, it can be polished this side, or I can have a structure like this, reverse of this, and polish is on other side. So this side will become reflective. Now, one of them is called concave mirror, another one is called convex mirror. Now, how to remember which one is concave and which one is convex lens? If I write concave, what is this word? This is cave. That's all. It's very easy to remember now. Rule number 1, always remember that we have to consider light is coming from left side. If this is a mountain and a lion is staying in this cave, he will enter and sleep here, right? How this structure is looking like this cave. And never get confused by this side of cave, because we have to remember that we'll always consider light is coming from left side, right? Now, this structure matches with this structure. That means this structure is concave mirror, and the structure whatever is left is convex mirror. So it's easy to remember. If it is looking like cave, it is concave, otherwise it's convex mirror, right? So we have some distance which is radius of curvature between P and C. Half of this distance is called point F or focal point. Point F or focal point. Now, if I keep an object here, then somewhere image will be made. Where image will be made, that we will study in another video. So it is going to be somewhere here and inverted. So let me write, this is object and this is image. If height of object is h and height of image is h dash, and the distance from pole to object, let me use another color of pen. Pole to object is u, and the distance from image to pole, this is v. We can write a relation. I am not going to drive it, we are directly jump into the relation. The relation is 1 by f equal to, f is the focal length, this length, equal to 1 by v plus 1 by u. Let me repeat. U is the distance from pole to object, v is the distance from image to pole, f is the focal length. So this is the relationship. One more thing, I will go to magnification. The ratio of size of the image to the size of object is called magnification. Let me write. Magnification denoted by m equal to h dash by h. H dash is the size of the image, h is the size of the object, right? Now this magnification can be found if we know u and v. Then what is the relation? Minus v by u. It's very confusing that where is plus and where is minus. I will tell you how to not get confused between mirror and lens formula once I do the lens formula. But one thing we have to remember, if we have plus here, then sign is opposite. Same will be the case in the when we go for the lenses, right? Let me repeat. When we have plus here, we have minus here. Okay, so what we have done? We have done laws of reflection, we have done types of mirror, two types of mirror, concave and convex mirror. This is center of curvature, focal point and pole. Distance between pole and object is u. Distance between pole and focal point is s. Distance between pole and object is v. Then this is the relation. Now the sign of these distance will the sign of these distances will change. It can be plus or minus. Now how to find that? Let me go one by one. First thing, thumb rule, always object we are going to keep on the left side because light is coming from left side when we are doing mirrors. So u is always going to be minus. Say if it is said an object is kept 15 centimeters in front of mirror, then we have to say u equal to minus 15 centimeters. Always minus. V can be plus or minus depending upon reference point, whether it is the left side of the reference or right side of the reference. Now before I go to that, let me revise you the basic. This is the graph. If this is origin 0 0, this side is positive, this side is positive, this side is negative and this side is also negative, right? In the case of mirrors, pole is reference. If I have this point as origin, if I go back to basic of graph, this side is positive, this side is positive, this side is negative and this side is also negative. That means if image is on the right side, it is positive. Image is on the left side, it's negative. Object is like this above the principal axis, then it's positive. If it is like this, then it is minus. If there is a calculation, some numbers are given. If I have say h equal to 2 centimeter and say h dash is 1.8, so here you are going to get value in minus. When it is minus, that means it is inverted. When image is positive, it is called erect. When it is inverted or below the principal axis, or if I am standing like this and my image is upside down, my head is down, legs are up, that is inverted. Otherwise, if it is like me, I am seeing head up, then it is called erect image, right? Let's quickly go to the laws of refraction. Before we go to laws of refraction, let's see what is refraction. In the reflection, what was happening, we had a reflective surface, we had a incident ray, and this ray was going back to the same side. Now in the case of refraction, what is happening? Say this is the block of glass, this is glass, and this is air. Now a ray is coming. Okay, one condition is both the medium, this is medium 1, this is medium 2, both the mediums are transparent, because if they are not transparent, if this is wood, then there is no question of refraction, light cannot enter in the wood, right? So both have to be transparent. For example, air, glass, water, plastic, transparent plastic, and so on. Now if this glass is not there, this block is not there, this ray is supposed to go in the straight direction. That is the property of the light, it will keep going in the straight direction. But what is happening at the point of contact, if I make a normal, based on if this density is high or this density is high, this ray which is going inside, either it will bend towards the glass or towards the normal, it will bend towards the normal or away from the normal. Now let us see, and I will tell you the thumb rule, that how to remember it in the exam, so you will not get confused. So in this case, this is the rarer medium and this is the denser medium. Density of glass is higher than air, right? Now if in this room 10 people are there, how they are standing? One is here, one is there, one is there. Okay, if I increase the density by increasing number of people or reducing the size of the room, in that case people will be standing very close to each other. If we are standing close to each other, that means density is high. When density is high, things are closer. That's the rule, remember it. Density is high, things are closer. This ray and normal are closer, so that means it will go in this direction. Let me use the blue color pen. It is going in this direction. Now again we have an interface. Okay, what is interface? The surface which separates two medium is called interface. One interface, air to glass interface, then glass to air interface. Now let me draw again one more normal. Normal is nothing but 90 degree or perpendicular to the surface or interface. Now this was supposed to go this way straight, but what will happen? Now it is going from denser to rarer, and as I said, if it is rarer, density is less, then people are far. So again density is less, it is far, so it is going away, going far, distance is more, going away from the normal. That means in place of going here, it will go like this, and these two rays, one is which was supposed to be the path if glass is not there, and this is the actual path when glass is there, these will be parallel. So that means there is a shift, and this distance or this shift is called lateral distance, right? Now laws of refraction. Like a reflection, we have two laws. One is very similar to first law of reflection, that means incident ray, refracted ray, and the normal all lies in the same plane. That means ray will not go like this, say if it is coming this way, this is the normal, this is the surface, so ray will bend in this direction depending upon the density, but it will not go either this direction or this direction. This all will be in the same plane. If I have a paper, I can draw on that paper. That is the plane, right? Okay. Now, first law is incident ray, refracted ray, and the normal to the interface all lies in the same plane. Second law is, if this angle is angle of incidence and this angle is angle of refraction, so second law says the ratio of sine of angle of incidence to the sine of angle of refraction is always constant. And this is called Snell's law also. So law number 1, ray of incidence, ray of refraction, normal, all lies in the same plane. Second is ratio of sine of angle of incidence, sine of angle of refraction is always constant, and that is called Snell's law also. We understood the concept that what is happening with the refraction, but in case there is a question in exam, what is refraction? So we can say in simple words, when light enters from one medium to another medium of different densities, it bends towards the normal or away from normal. This bending of the light is called refraction, right? Now, this concept of refraction is used in lens. Again, lenses are of two types. Lens can be like this, or lens can be like this. Again, going back to light comes always from left side, this side. So now we have two surfaces, one is this side, one is this side, one is this side, one is this side. We will not worry about right side of surface. We'll always say left side of surface, because light is coming from this side. And when we see left side only, our problem is simpler. Say, if I see like this, it looks like this to me. And if I see only left side of this, it looks like to me. And this is like cave. So this is concave lens. This another one is convex lens. So we have these lenses again. This is principal axis, then the center of the lens. In this case, center of the lens, this point is represented by O and called as optical center. Here is the optical center, right? Now, here in this case, we'll have two focal points. One is on the left side, one is on the right side. Okay. In 10th standard, the radius of left side of curve and right side is same, but if you go to 11th, then it can be different. So for 10th standard, this distance f1 and f2 is always same. So again, like mirror, if I have an object and I have an image, height is like earlier it is h, this is h dash, distance from optical center to the object is u and to the image is v, right? And this is the focal length. Now formula is 1 by f equal to 1 by v minus 1 by u. Again, magnification is h dash by h like earlier, but remember, now it is not minus v by u, it is v by u. As I said earlier, if this is minus, then this is plus. So we always have to remember these cannot be of same sign. Right? Sign convention remains same. If it is on the left side, minus, on the right side, plus, above the principal axis, plus, below the principal axis, minus. Same, like mirror. Now, confusion is, in this case, focal length will be plus, or in this case, focal length will be plus. How to remember? Now, it's very simple. Again, look for the only left surface. If surface is this left side, then to make this surface, if I have to make a circle like this, center will be somewhere here, and this is on the right side, and right side is plus. So for this mirror, that means convex mirror, f will be positive. And for similarly, again I will see only the left side, and the sphere is drawn like this, center will be on the left side, and left side is minus. So this will be minus. For concave lens, it is minus. Right? Now, in exam, how to remember? I have two formulas, 1 by f equal to 1 by v plus 1 by u, and 1 by f equal to 1 by v minus 1 by u. Now I am getting confused whether this is for mirror or this is for mirror. So always remember, we go plus to minus. First plus, then minus. What we studied first? Mirror. And where we go? Plus to minus. So first formula is plus, and we studied first mirror, and then we went to lens. So first formula is plus and second is minus. Now m equal to minus v by u or m equal to minus v by u, which one is correct? As I said, they cannot be of the same sign. If this is plus, this is minus. If this is minus, this has to be plus. So this is easy way to remember this. Right? I hope this was useful and you like this video. Please keep writing comment and suggest the topic which you want me to cover in my coming up videos. Thanks a lot. Thanks for watching.